in linear algebra, we also often talk about eigenvectors and eigenvalues. We'll have an eigenvalue lambda and vector I'm going to write it as a V with an arrow, right? So an eigenvalue and an eigenvectors are concepts that appear kind of predominantly in the analysis of linear transform systems. So the boring mathematical definition is that if V is an eigenvector and T is a linear transform of itself, then V is an eigenvector of T, right? So we write that as T, well, that's not quite what I want. T of my transpose of my eigenvectors is equal to my values of my eigenvectors. My eigenvectors, sorry, my eigenvalues times my eigenvectors. And there's a couple other ways to write that. If we do it in matrix notation, we'll often write something like this. So this is my attempt to tell you that this matrix A is bold and this matrix V is bold because they're matrices, then that's going to equal to my eigenvectors, sorry, my eigenvalues times my eigenvectors. So that's the mathematical way to introduce these. This has always been a bit confusing to me. I'm not a big fan of it, right? Mathematically, it's very correct. Obviously, right, I've never been able to find a hole in the mathematical theory that's been accepted for 200 years. But that doesn't mean it's intuitive to me. So I like to think of eigenvectors and eigenvalues like this. And this is not true for every case of it, but it is true for how we use it in this class. Well, it's not untrue, but it's very helpful for how we use it in this class. All right. Matrix A. Whoop. So matrix A acts by stretching the vector V and not changing its direction. So V is an eigenvector of A, right? So if I take a vector and I stretch it along a certain direction, if I do the transpose, right, anything along that vector is going to remain an eigenvalue and an eigenvector, right? So an eigenvector does not change direction, right? But now I don't know from an eigenvector eigenvalue approach how far it's moved, right? I just know that anything in that transformation that stays on that line is an eigenvector, right? So if I stretch this square, if I compress this square, anything that's on this line is going to stay on this line, okay? So that means that it's an eigenvector, and then an eigenvalue is simply how far it moves along that line. There's actually a really good GIF on Wikipedia of this. So if you want to go to the Wikipedia page on eigenvectors, you can kind of stare at that GIF for a while, and you'll see the dots move and come back. It's quite helpful. So again, we are going to kind of give you a precursor here. For us, eigenvectors are related. I don't know how to write related. Related to mode shapes and eigenvalues are related to natural frequencies. If you want that in notation, that's our little u vector, and that's omega. Right, so that's what you need to know. My mode shapes come from my eigenvectors, and my frequencies come from my eigenvalues.